All right, let's get right to it. You've got an exam coming up, and we need to nail homeostasis. This is your high yield review. We're only covering what you absolutely need to know to ace this thing. No fluff. Ready? Let's go.
So let's start with the big question. Why is this so important? Well, to put it bluntly, if homeostasis gets disturbed, things go very, very wrong. We're talking illness or even death. It's literally the foundation of being alive and healthy.
Okay, so what is it exactly? Homeostasis is basically your body's internal thermostat. It's this amazing ability to keep your internal environment stable and constant. You can think of it like a nonstop balancing act, making sure your cells have everything they need to do their jobs. You've got to know this definition for sure. Okay, so if it's a balancing act, what exactly is being balanced? Let's jump into our first section and look at the checklist of things your body has to keep under control 24/7. All right, this is your must-know list for the exam. Your body is juggling a ton of things. The amount of nutrients, oxygen, and CO2 floating around, the concentration of waste products, and, of course, water and electrolytes. And that's not all. It's also managing your temperature, your pH, and your blood pressure. These are the big ones. You've got to have these down cold. Okay, now we're getting into the pure memorization stuff. These are the vital set points, the exact numbers your body is trying to hit. So, get your flashcards out because I can almost guarantee you're going to see these numbers on your test. Right. So for every single one of those things we just listed, there's an ideal target number, and we call that the set point. Let's run through the big ones you've got to know. First up, temperature. Your body's ideal set point is 37 degrees Celsius, which is 98.6 Fahrenheit. And why does this matter so much? Because all the enzymes in your body, all those chemical reactions, they need this exact temperature to work. Go too hot or too cold, and everything just stops. Next, let's talk resting heart rate. The textbook target for an average adult is about 70 beats per minute. Now, yeah, in real life, this can be different for everyone, but for your exam, 70. That's the magic number you need to remember. Okay, how about breathing? Your respiratory rate. The set point there is about 16 breaths per minute when you're resting. It's the perfect rhythm to get oxygen in and carbon dioxide out, nice and steady. And here's a classic you will definitely see: blood pressure. The gold standard set point is 120/80. You know the drill. That top number is the pressure when your heart beats, and the bottom one is when it's resting between beats. Okay, this next one is a big deal. I mean, it's so critical that your body has almost zero room for error. We're talking about blood pH. The set point is 7.4. If that number budges even a little bit, it can cause huge problems for your entire body. Let's talk electrolytes, specifically plasma sodium. Its set point is 142 milliequivalents per liter. And hey, don't get hung up on the units. It's just a fancy way of measuring concentration. The key thing to know is that keeping sodium right at this level is essential for your nerves to fire and for keeping your body's fluids balanced. And last but not least, plasma osmolarity. Sounds complicated, right? But it's really just a measure of how much stuff is dissolved in your blood. The target number is 290 milliosmoles per liter. This one's super important for controlling where water goes, in or out of your cells. So really, take some time and lock all these numbers down. Awesome. So we know what the body regulates, and we know the target numbers it's aiming for. But how does it do it? Now we're going to get into the control systems, and we'll start with one that trips a lot of people up on exams: positive feedback loops. Okay, so here's the thing about positive feedback. It's kind of the opposite of what you'd expect. Most of your body's systems are designed to stop or reverse a change, to bring things back to normal. But positive feedback? It does the opposite. It amplifies a change. It pushes it further and further in one direction until, bam, a final goal is reached. And then, and only then, does the whole loop shut down. The classic example you'll always see for this is childbirth. Just follow the chain of events here. The baby's head presses on the cervix, which creates a stretch. That stretch sends a signal to release the hormone oxytocin. What does oxytocin do? It causes stronger contractions. Stronger contractions push the baby's head even harder on the cervix, which means more stretch, which means, you guessed it, more oxytocin. It's a runaway train that keeps getting faster and faster until the final goal is met. The baby is born. That's what stops the loop. Okay, here's another great example, blood clotting. So you get a cut, the inside of your blood vessel gets exposed, and platelets start to stick to it and get activated. But here's the cool part. Those activated platelets release chemicals that basically shout, hey, party over here, and they attract and activate even more platelets. It's a pile-on effect that rapidly builds up a plug to seal the wound. See how it amplifies itself to get the job done? It's another perfect example. So there you have it, 2 key examples of positive feedback. They're super powerful, but honestly, they're pretty rare in the body. Which leads us to a final thought to chew on. If these explosive, amplifying processes are positive feedback, what's the opposite? What's the system your body uses like 99% of the time to stay in balance? That's the next thing you need to lock down. You did great today.